Hi, in this video we are going to work out the area for non-right angled triangles. Okay, so for right angled triangles, we should know we have the formula of a half base times height. So for non-right angled triangles, we've got our own formula. So let's label this triangle first. Don't label all of it, just the parts you need to know. We can label these two sides as A and B, and the angle in between them as C. Then for the area, it's just going to be half A times B times sine of C. Okay? So again, note that down, something that'll be fairly important for the rest of this video. So first, let's start with two basic cases. Find the area of these two triangles. So formula was half AB sine C. Here to remember it is you have two lengths and the angle in between them. So let's label it. Again, A and B don't matter, but C has to be the angle. And we're going to work that out. We just put it straight into a calculator. 1/2 times A, which this question is 4, times B, which is 9, times sine of 120. And that gives me 9√3, or as a decimal to rethink figures, that is going to be 15.6. So the area of this triangle is 15.6 centimeters squared. Okay, so all of them just use that single formula. One more example, the same idea. Formula is a half AB sine C. Again, it's going to be the two lengths and the angle in between them. That means this must be A and B, and this is angle C. So for this question, I didn't need the 13. So it's always the two lengths and the angle in between them. Then we just go straight to our calculator and plug it in. So 1/2 times 11 times 5 times sine of 100. And again, to three significant figures, that is going to be 27.1. So the area of this triangle is 27.1 centimeters squared. So that's basic problems going forward. That's fairly straightforward. We'll also look at the reverse problems. This is where we have either a side length or two side lengths or an angle missing, and we need to find them given the area. So here we start the exact same way. We're going to write the formula down. The area is a half AB sine C, and we're going to plug in what we know. So we know the area is 20, we're told that in the question up here. Let's label my triangle. Again, A and B can go in either order. So it's going to be a half times x times 8 times sine of 30. Okay, so all done there is plug in what I know. Let's plug in A, B and C with what they are. Now I want to find x. We have x being times by a bunch of stuff, and of course the opposite of times is dividing. So everything x is being times by, these three terms, I'm now going to divide by them all. So 20 over 1/2 times 8 times sine 30, and that will give me x. Okay, once you've done that, once you've got x by itself, we can now just reach for the calculator. Plug that all straight in, and that will give me the answer. So working that out, in this case, I get x being 10. So here x was a missing length, so it's going to be 10 centimeters. Also, you can quick check that looks fairly reasonable. You have this 8, and it's a similar length to this 8, so 10 does look about right. Again, these aren't drawn accurately, they aren't drawn to scale, but they're not going to be misleading. If I got x being 2.4, obviously something is going to be wrong. Okay, here's the same idea, but now we need to find a missing angle. So find x given the area. We start the exact same way. Write the formula for area down. Area is a half AB sine C, and we plug in what we know. So the area is 26. That's going to be a half times 12 times 13 times sine C, or in this case sine x. Just as before, we have a bunch of stuff being times by it, and again the opposite of times in is dividing. So if I do 26 over all the highlighted terms, I now have sine x by itself. That will give us sine x. We then need to undo that and the opposite of sine is going to be sine to the minus 1. So if I do sine to the minus 1 of all this stuff here, then what I'll be left with is going to be x. And then from there, we just plug it all into our calculator. So sine to the minus 1, and plug in that fraction. Note for this question, there's also a special case whether the angle is acute or obtuse that I'm not covering in this video. Just be aware that does exist, so you might look at it for the more harder questions. So here I get the angle being 19.5 degrees to three significant figures. Again, you can check your triangle and see does it look reasonable. And yes, here x looks like it could be possibly around 20 degrees. Okay, moving on, I was going to finish with a couple of exam style problems. So here, roughly the same format. We're told the area of this triangle is 24 centimetres, and we need to find x. Again, we're going to start the exact same way. Then we label our triangle. Which ones A and B don't matter. So 24 is going to be a half times x times 2x times sine 60. Okay, let's see what we can do here. So we've got quite a few terms going on. I'm going to see if I can simplify some of this stuff first. So basically, these equations you can only really solve quite comfortably if x only appears once. Because if x appears twice, that's going to slightly confuse things a bit. So let's see if we can group those together. In fact, it's pretty easy. If I just look at those two terms, x times 2x is just going to be 2x squared. Okay, I'm going slightly further than this. If I look at these two terms, 1/2 times 2x squared will just be x squared, because 1/2 times 2 is just 1. So now I've got 24 equals x squared times sine 60. So whenever x appears more than once, it really helps you do some algebra first to get, in this case, x squared by itself instead. Now, to get x squared by itself, opposite of timesing by sine 60 is going to be divided by it. That will give us x squared. But we don't want x squared. We want x by itself. And the opposite of squaring is going to be square rooting. I'm going to type that into my calculator. So square root, and then plug that fraction in. That gives me x, which to three significant figures is 5.26. Okay, so again, the steps didn't really change. The only difference here was we had x appearing twice in the question. Okay, last one. So often this topic ends up being merged with circles. You may see more in future videos. Here we find the area of this following shape. So we have this bit, which is part of a circle, and then this triangle that we've just been doing. So hopefully, obviously, you can see that to work out the total area, we're going to break it down into my circle bit plus my triangle bit. So let's do that now. Let's do the triangle bit first. We've just been doing that. That formula will just be 1/2 times A times B times sine C. Okay. Now, for the circle, we want to find the area of a sector. For that, we need the area for a full circle times by what fraction of circle we have. So for a full circle, we would use the formula pi r squared. And we can see here, actually given a radius, this length here is the radius. I should mention, sorry, that in this question you would have been told that this point here is the centre of your circle. So the area for a full circle is going to be pi times 5 squared. We then need what fraction of circle we have. Normally do this based on the angle that's inside the circle. Right now we don't have that. This angle is outside the circle. What we want now is this angle here. And again, we should know that angles around a point always equal 360. So if I do 360 take away 140, that tells me that this angle is 220 degrees. Now I know that then means the fraction of circle I have is 220 degrees out of a possible total of 360. And then we're done. That's for my circle sector, and that's for my triangle. We can now just work them both out, add them together. In fact, we just type that straight into our calculator, and that will do it all for us. So pi times 5 squared times this fraction, and then just add on the exact same stuff, or not the same stuff, add on the stuff for the triangle. And there we go. The area of those two shapes combined to three significant figures is going to be 67.3 centimeters squared. Okay, and that's it for this video. Hope it was useful, and thanks for watching.